Hello everyone, my name is Victor Fagans, and today we're going to be reviewing what we talked about in class this past week, which was Intro to Dataframes. And so let's get started. So first thing we did in class was review a common error, right? Is talk about kind of what is an R object and what is like a value. And so for example here, I have the word Joe typed out, and right? This is an object that's called Joe. So when I run this code, so I'm going to press Control Enter to run this line of code. You can see here on the bottom, I get object Joe not found. And that's because there's no value associated with this object. So if we look to the right here, we can see that here that the environment is empty. There's no objects that are stored in my environment so that I can call them. So that's different from this, which is the character value Joe, right? So this is the word Joe, and I don't get any error when I use that. It's just in quotes Joe. But if I want to save that value into an object, I use the assignment operator, right? Which is this less than dash symbol. And when I run this line, now I have something in my environment. I have an R object in my environment, name person quotation Joe, right? So then when I call this object name person, right, I get the value Joe. And so, yeah, so right, so these objects need to have some value assigned to them before you can use them, or else you're going to get that error object not found. Okay, so let's move on. We talked about creating a data frame. So a data frame is a collection of multiple vectors. So here we created 3 vectors in class: shape, name, color, and size, that have 3 values in it. So when we run all this, so I'm going to highlight this all and press Control Enter to run all those lines of code at the same time. Now you can see I have the 3 vectors in my environment: color, shape, name, size. And to create a data frame, there's a data frame function, data.frame, which we can feed vectors into. And I'm going to save that into an object called shapes data. So now I see on the right in my environment, I have this shapes data object. And now when I call this, when I run it in the console, I can see what it looks like. So you can see here we have 3 rows: cube, sphere, cylinder, blue, yellow, red, 603. So we can see that this table is what was created, right? This is the data frame. And when we made those vectors, order matters, right? So for example, a cube has 6 sides, right? If we wrote this vector, the 603 vector, right, the sides vector, in a different order, that wouldn't be correct, right? So if we said the cube had 0 sides, the sphere had 6 sides, the order matters because we need them to line up and match. Okay. I also showcase the documentation. So as we go on throughout our summer and learning, we're going to be introduced to more and more functions. And as we learn more functions, it's going to be harder to kind of keep track of them in our head. So using documentation and online resources is extremely helpful. So I showed this question mark and then giving it a function will, if I run that line, it's going to open on the bottom right here. It's going to open a help tab and it's going to give me information about that function. And so usually you're going to get a lot more information than you need. And so you can see here that this data frame objects function creates data frames, right? And you can see here, this is the arguments of the function. So it lists all the arguments of a function, right? So we have this dot, 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 and we can see here, what does that dot, dot mean? These are arguments of either the form value or tag, or component names are created based on tag presence. So basically what this is saying is the dot, dot, dot is like your vectors. You feed your vectors in, and there's all these extra arguments that we could use and we can read about. But since we use the function the default way, and it worked, we're not going to pay attention to those arguments. Right. The other way, instead of using a question mark, is using the help function. The help function will achieve the same thing, where it'll open up the help pane and give you information about the function. Sometimes documentation, even after reading the documentation, you may not understand how the function works, or you might need extra assistance. And that's where the internet is really helpful, to Google oh, let me look up this function. Let me see how it works. I want to see some examples. I want to see someone talk through it because reading this, it's not clear to me how it works. And so that is completely valid, and we do that all the time. So let's now explore the data frame. So here I'm going to use the names function. So when I run the names function on our data frame, what that does is it gives me the names of the columns, right? So the names of the columns are important to know how they are represented because R is case sensitive. So we need to know how these columns are spelt, right? Is this capital S sides or lowercase s sides, right? We need to know how it's spelled. So looking at the names of the columns, that's really important when later we're going to be selecting these columns or using these columns for things. Another handy function is nrow. Nrow, it gives you the number of rows in a data frame. So if I run that on shapes data, we get 3 rows. So which we had our vectors were length 3 when we made them, so that makes sense. Another handy function is the summary function. The summary function, when it's run on a data frame, gives you some quick statistics and view about kind of what are the data types of your columns, right? So we see that shape name, its length is 3. It's a character. Color, it's length 3. It's a character. Sides, because sides is a numeric column, it gives us some statistics here. So it gives us the average, the mean, the median, the quartiles, the minimum, and the maximum, right? So sometimes it's useful to run summary on a data frame to get a very quick overview of what my data frame looks like. Another handy function is this str function. So last week we showed str stands for structure. It's good for like kind of seeing what's the data type of a vector. We can use that same function to explore our data frame. So we can see here, this data frame has 3 observations, 3 variables, and you can see here, here's the names of the columns. You can see what the column's type is, right? A vector. So this is a character vector, character, numeric, right? And we get a little peek of what is actually inside that vector. So these functions are good to examine kind of a high view of how your data is organized. What is it? What are your vectors represented? Are they characters? Are they numeric? And it's good to know that. It's good information to have. So when selecting columns, so normally we'll be working with a particular column, right? We may want to take the average of a column or wanting to know the particular values in a column. So there's 2 ways in R to kind of get access to a column. So I showcase this $ notation. So $ notation, you use your data frame and then you use the $ symbol and then you use the name of the data frame, right? And so you can see here there's no quotes around this $. It's just the object. And because the reason we don't have to use quotes is because it's this $ is kind of linking these 2 things together because the object color is inside of the shapes data. So we don't need any quotes when we use the $ notation. So when I run that, I can see here now here's the vector of the color values, blue, yellow, red. I introduced the bracket notation before. So the bracket notation is the same way you can use it to select a column, right? Where you use your data frame and then you use your brackets. So the bracket notation, it takes 2 values because the data frame has rows and columns. So the first value, if you want to have all the rows, you leave it blank and then you do a comma and then you're interested in the column color, right? And so we use quotes here because the $ notation, we're using brackets. And so the link to the shapes data is not as explicit, so we need to have quotes. And here we get the same information. The bracket notation is more flexible than the $ notation because you can also have row numbers. So if we're interested in looking at the first row in the color column, we could do that, right? And get the first value, right? So we can do index by rows as well. So now we talked about reading in data. So reading in data, you're working with a file on your computer, and so we need to learn how files work on your computer. So so we talked about absolute paths and we talked about relative paths. So absolute path is like the absolute location of a file on your computer. And it usually looks like this, where you have kind of the beginning of your computer, like this is the starting point on your computer, and then it goes into different folders. It goes into different folders, until it gets to the particular file you're interested in, right? And so this is the absolute path, right? It's the full path of where the location is, right? You can think of it as like coordinates. If in geography, right, it's latitude, longitude. It's the exact place where a file is. I also talked about a relative path. So a relative path is based off the working directory. So this function, getWD, tells you where your working directory is. And so you can see my working directory is the following, right? And it'll be different on your computer, right? We have different computers. And I can use this working directory as like the starting point to specifying where my file is. So if I say, right, educationdata.csv, and this was in my working directory, then I would get access to that file, right? I don't need this absolute path, the full directions. I can use a relative path. So like, here's my starting point. I can say take, 2 steps to the right, and then I get my file, right? Relative directions versus, hey, here's the absolute location. So you can change where your working directory is by using the set working directory function, right? Well, it's not going to work because I didn't specify the argument directory in the function. But you can use this function to set a directory, right? You can do that manually. And I advise against it. I recommend using the R projects instead. So R projects is when we did this at the very beginning of class, is this on the top left here, we have let's see here, new projects button, right? And we can say new directory, existing directory, right? And when you're using R projects, you create a R proj file. And when you open that up, it's going to open your project, and that's going to specify your working directory automatically as to where that file is. So you can see I'm working in my Summer Stats Workshop project because that's where I keep my learning materials. And on the left here, on the right, sorry, you can see here's my .rproj file on the very bottom there. And that sets this directory as the default location of my files. And that's really handy because I don't have to type out the full absolute path when I set my directory. It's built in. And so it just saves you a little extra time and also makes you able to collaborate easier, right? So this absolute path, even if I open my code on a different computer, right, this path is going to be different because every computer is going to have a different location of where you stored your code, where the directory is. So having it automatically set to with an rproj file is very handy because it makes you be able to work across different computers more smoothly. Okay, so now that we've covered file paths, let's talk about reading in data. So there's a read.csv function, right? And the read.csv function takes the input of a file path. So because we're using a relative path, we don't need the entire full directions of the path. We can just say education. Well, actually, it's education data in my directory. And if I run that, it's going to see in the console, it's going to output the data frame of reading in the CSV file. You can see here's all the information that's contained in that file. Let's see. So CSV file stands for comma separated values. And there's a lot of different data files that exist. And so you can Google, how to read in blank data file if it's like a new data file that you haven't seen before or you're not familiar with. Okay, so when I ran this read.csv function, it just outputted it into the console, right? Which isn't interesting. I want to work with this data, so I need to save it into an R object. So here I have education data. I named it. This is my object, and I want to save this data after reading it into this object so that I can keep working with it and do the different things I want to do with it. Look at statistics, select columns, create new columns, things like that. So when I run that now in the environment, so I'm going to look at the environment tab on the right, we can see now I have this education data object in my environment, and it tells me how many observations it has and how many variables it has. So now let's start looking at this data file, what this data tells us, right? So we can use the same functions that we used before, and row, right, tells us how many observations there are in the data sets. The names tells us how many the column names are, right? So when you're working with a brand new data file and then you're not familiar with how it works, it's really important to check these things because, like I said, the spelling matters on the columns, because if we want to use, for example, the race column, we need to spell it exactly how it is in the data. So the summary function here, if we use it, we're going to get input on our various statistics. So this data frame is a lot more complicated than the one that we made. So for each column, we get outputs. So we see that sex, race, FRPL is character, PARE is character, and then for our numeric columns, we get the simple statistics, the mean, median, min, max. Okay. And so, right, another handy function to work with is called the head. So this data frame has 25,000 observations, right? So when I put it in the console, education data, it's going to output the entire data frame, or at least to a certain limit. And this can be kind of hard to look at, right? If I wanted to have just a quick glance of this is hard to look at. So there's a function called head, this head function, which gives me the first several observations. So when I scroll up here, and I'm going to make my console a little wider so that maybe I can get everything on one line. You see it gives me the first 6 rows, and so I get to see the first 6 rows of my data frame, and I get to see, okay, this is kind of what are the values contained here. Okay, there's some missings here, and we're going to talk about that later. So it's good to get a good glance, right? So the head function, right, if you've never seen it before, you can look at the documentation, the question sign head, right? When I run that, it's going to open up the help panel. So I'm going to open back up the right side and the help. And I can see here the instructions of how to use head, right? Return the first and last parts of an object. And so on default, right, it takes an object, which is X, and then N, which tells you how many like rows do you want to look at. So the default's 6. And so you can see here X is an object, and then N is either a vector of length, or 1. It's pretty, this is a lot of information, right? So it might be just quicker to just like see how it works than to actually read this whole thing and be like, oh, that's a lot of info. So if I say n equals 10, right, I get the first 10 rows. See, first 10 rows. Okay. And because when I had this panel open, the next column gets pushed down to the bottom here because there's not enough space to have it all wide out. All right, so now let's talk about selecting columns. So we can use that $ notation to look at a particular column. So when I say education data $PRRED, right, I can get the full vector of that observation. And you can see here, this is all the values in that vector. So when this is a character vector, you can see here that it has quotes around the values. And so a useful function with working with character vectors is the unique function. So the unique function gives me all the unique values in this function. So you see here, I can see some college, high school, bachelor's, less than high school, graduate. And then I have this blank here where there's just no value. It's just it's just quotes. And so this is really useful to kind of get an idea of what this column is, right? So the name of this column in our data file is PARED, right? And looking at these vectors, we see that we can kind of get insights on what this column might mean. For example, this is probably going to mean parent education, right? And so this is the parent education of the students in our data frame. So, and sometimes this isn't clear. Like sometimes you still need to talk to somebody or look at the documentation of how a file was created to understand what the columns mean. So you don't always want to trust, like just looking at the values in the data frame, what is this? Oh, this is what this column is, because you could be wrong. And so you always want to be careful when you're unsure of what a column is. Ask the person who created the file or look for some kind of documentation. So when working with numeric columns, for example, this FA read is, don't want to move that, is a numeric column, right? It represents fall reading score, and so it's a bunch of numbers of each student's fall reading score, right? When I run unique on this, it's going to give me all the unique numbers in this data frame, which isn't particularly interested, but sometimes when doing that, you can see something really weird. Like for example, if I saw like the number 999 in here, I would be like, oh, that looks weird. That's probably not supposed to be there. A handy function for looking at numeric is the range function. The range function will give you the minimum and the maximum. So when I ran that, this is not the minimum and the maximum. These are NA values. NA values. So what is NA values? What does that mean? So let's put a side view. So NA is a special value that usually indicates like a missing value. It's missing. There's not an applicable value, right? So NA is capital N and capital A, right? Is a special value, right? Other special values that we've seen before is capital all caps true and all caps false. So these are all special values. NA indicates like a missing, whereas true and false are those logic special values, right? And that's like so that when you type in like NA is an object, right? When you type in NA, capital NA, right? That's not an object, it's a value. And so how NA works and what's the trickiness with NA is usually whatever it touches, a function that has NA in it will usually output NA. So here's a vector that I made, 1, 2, 3, 4, and if I take the sum of that vector, I get the number 10. But say if I add NA to that vector, I get NA is the result. So what do I do about that? So first, let's look at the documentation of sum to see if that gives us insights of how to handle NA. So on the right here, I'm going to make this a little bigger. I can see that, right, sum of vector elements, it adds things up. But there's an argument in this function called na.rm equal false. So what does this mean? Here on the arguments, we can see should missing values be removed. On default, right, it's false. So this na.rm equal false, that's like the default behavior of this function. So it's going to say don't remove, false, don't remove na. So if I wanted to remove na, I need to set that equal to true. So here I'm calling the same function, the sum function. It has the same input as before. But now I'm going to say na.rm equal true, right? And that's going to give me 10. So that removed the missing value, right, by specifying this extra argument saying that that is true. Now if we look at the range function, we can see that the range function has that same argument. It uses na.rm equal false. So on default, it's not going to remove na. And we need to set that to true if we want to remove na. So here on range, when I do that, then I actually get real values instead of na. I get 0 is the minimum, 19 is the maximum, right? So for fall reading scores, the scores seem to vary between 0 and 19. So we can use other functions, right? So the mean function takes the average. So if I feed that fall reading score column into the mean function, I get na. Na. So the mean function also has the na.rm argument, so I need to set that equal to true. And now I get a real value. And so I now see that the average fall reading score is 9.21. So now let's talk about kind of creating new columns. And so usually we want to create new columns that are based off the columns in our data set. So in our data set, we have this SP read and we have fall reading, right? So what those columns is the fall reading scores and the spring reading scores, right? So in an academic school year, they record students' fall reading scores and the spring reading scores. And if I take the difference of those vectors, so if I say spring reading score minus fall reading score, that's the change in their reading scores. So I might be interested in seeing how do students change throughout the year? Do they grow? Do they get smaller? Things like that. So when I run that line of code, I get a vector. It's just going to output to the console all the values of the change, right? So I get, you can see here, I have NAs, I have minus signs, I have positive signs, values. I get a lot of values, right? And to save that, a way to save that is to save it as an extra column. So here I say education data, and I use the $ notation, and I say read change. Read change is the name of the new column, right? So read change, it doesn't exist in the data frame. So if I just run this, so I'm going to copy and paste this into my console. So we can see what will happen if I run that. If I paste it, I get null, right? Null is also a special value, but it just means like you didn't get any output because read change wasn't a column in my data frame, right? So, but I can create that column, right? So I say, I do the assignment and I say, right, I take the difference, right? Spring reading minus the fall reading score, right? Both of these are columns inside of the data frame. And I save it, right? I assign it to a column, read change. So I'm going to run that line. And now, now when I'm going to copy and paste this into the console, I actually get values, right? So it properly saved that vector of the differences into the column in education data. So when I now run the names on education data, you'll see here that here were the names of the columns, and you'll see here's now there's a new name. There's the new column that we added, read change. Right? When we look at the head, so I'm going to put this to the side a bit so we can get all the columns in one output. Oop, not close, but you can see now read change is included in the data frame. And then we can also look at the average of read change, right? So remember I have to set NA.rm equal true because this NA is included in the difference, right? So I get a value of 0.99, right? So what this means is that on average across our data, there was a 0.99 increase in reading scores from fall to spring. Now you may ask yourself, what does that mean? Is that a lot? Is that a little? Like, is that good? Is that bad? And this is where you'll need to know the context of your data, right? So just looking at the data by itself isn't enough to answer that question, right? Is this a lot? Is this little? Is this good? Is this bad? You need to know the context. Like what is reading score? Like is a 1 point increase a lot? Does that mean from like B to A? Or like you need to know the context, right? So the data by itself, the data file, just the values don't give us that context. So we need to talk to some people, the people who created this data set, the people who are interested in knowing the answers, right? So that's an important thing to recognize that not everything about a data set can be contained in a data frame in just values and columns. So now I showed how to save a data frame. So there's a write.csv function. So when we look at the documentation on that, I just ran the question mark write.cv, and I look at the right here. I can see that we saw this before in class, but sometimes documentation contain like a family of functions. And a family of functions, you can see there's 3 functions here. They're put together like this because they behave very similarly or have the same arguments. And so write.csv, it has x, which is an object to be written, right? So we want to save our education data, and file, which is a character string, like it's like the location of where we want to store our file, including the name of the file. And so when I run that function, right, so I say write.csv, and I give it our education data, right? So this education data that we're about to save is different from our original education data, right? The CSV file, right? Because we added a column to it. It's different. And so I'm going to file, when I give it a file name, I'm going to give it a different name to show that this is different, right? So I'm going to show like today's date, June 21st. Well, actually today's date's like June 23rd. So I'm going to say June 23rd. And yeah, and then when I run that line, it's going to save it in my working directory, this file, right? And if I want to save it somewhere else, somewhere completely different on my computer, right, that I don't, it's going to be really annoying, like for the reference, the starting point being my working directory, I can use an absolute path here. But for this case, I can just use my working directory and the relative path to say this file. Okay, and that is everything we talked about in class this week, and keep a lookout for the homework video, and that's going to be um, working on these processes, right? How to read in data, how to create new columns, how to use columns to calculate statistics, as well as examining data frames and seeing if there's anything weird in the data frame. Okay? Thank you.